So let's go over testing in respect to bugs. Let's actually discuss what a problem is. What are we looking for whenever we are testing? And that is this idea of bugs. So bugs are basically a deviation from expected behavior. And we have to kind of consider, is it a bug or a feature? Because if we don't have an idea of what the expected behavior is, how do we know if we're deviating from it? One person could look at the software and have an expectation of that software, and then they might think that the software is working perfectly fine. While someone else might have a different expectation of what that software should do. And when they click something unexpected to them happens, and therefore they think it's a bug. So we need to figure out if it's a bug or a feature. We need to figure out what is the software supposed to do, and is it deviating from that? And bugs can be both an error, so basically a breakdown of the entire code, the part of the code that actually leads to the failure. Or, the error terminology here, it's not the specific level of a bug here. This is more, I think they call them a defect is the technical term here. So bugs can be both a defect or an error is what the common nomenclature, the common way of saying it is, and a deviation from expected behavior. So it could be both a system ending thing. So we click on it and the whole system crashes, or just a slight deviation from expected behavior. We put in 3 plus 3 and it equals 7. It did some calculation because if we do 3 plus 2, maybe it equals 6. So it's doing calculations, but there's a deviation in this expected behavior. And it looks like maybe with this that there's a plus 1 happening, an off by 1 error somewhere in the code. But so that now if of course we did 3 plus 3 and we just got, error, and the whole program crashes, that's also a bug. Those are both in the same category. So we need to look at, again, what are we expecting? Is it deviating? Is it crashing? And then we can sort of categorize it and figure out how to fix it. And so we have this sort of specific terminology, this idea of a failure, an error, a fault, and this entire idea of a bug can again be sort of put into the category of a defect. So a failure is the event by which the code deviates from the expected behavior. So the event meaning that the actual breakdown of the code. So we have, if we're writing a bug report, the failure is what we might put in the title of the bug report. Program crashes while doing this. That is the actual failure. The error is the part of the code that leads to the failure. So if we actually look in the code, the code, let's see, the lines of code here, this down here, maybe that is the error. That is the part where the code is actually deviating from expected. And then the fault is what the outcome actually was. So we have an input, and this is the expected output. The expected output is over here. But what actually happened over here is the fault. This is the change, what actually ended up happening. And that is what we might put in the fault. So we expected A, but we got B. And so that is where the fault comes in. And so testing can be used to show the presence of bugs, but never to ensure the absence of them. That's very important, is that we could test the program 1,000 different ways, but it's never going to get to the point where we can ensure the absence of them. And this is actually sort of a little, I need to put a little asterisk here, because you can actually ensure the absence of them, but it's very, very complicated and you have to mathematically prove every line of code. Meaning you have to come up with equations that prove that each method, each system cannot have errors in it. And this is extremely costly and usually only used in something like maybe missiles, defense systems, NASA, so like a space exploration, or high security things like government entities. And even then, it isn't typically insured completely. It's like just 99% insured. It's very, very hard to ensure the absence of them. And again, whenever we say the ensure the absence, we're talking about we could get most of the bugs out of it, but we're saying that we can never guarantee 100% of bugs have been checked unless we do that sort of mathematical proof, which is almost impossible, so we won't even talk about that. So just keep that in mind, is that we can test it, we can find the bugs, but we're never going to be able to say that, oh, because all these test cases worked, there are no more bugs in our program. We can never really get to that point. And here's just a sort of an interesting little graph here of the life cycle of a bug. And you can see that it's a little bit of a complex process. We sort of get a bug that comes in, and it comes in an unconfirmed state. And then with this, we have to categorize it. So we have these steps. We first assign it to someone to do it. Maybe the ownership changes. It goes in this sort of fashion. And then we have to, figure out the bug. We're going to then put it into a category of, whenever we're working on the bug, was it fixed? Was it a duplicate? Has this already been reported? Maybe it's a won't fix, which means that it's not actually that important and it'd take way too much time. There's more pressing matters at hand. Works for me. This one's actually pretty typical. If you don't have, whenever people report bugs, they need a very specific step-by-step to get to that bug. Otherwise, a programmer might look at it and go, well, I did this and it works perfectly fine. They didn't understand that all of these additional steps were used, and therefore it sort of comes back as a works for me. You can't fix something you don't actually see breaking. So a lot of times that will happen with a bug. Invalid means maybe it's just not a bug. Maybe it's a feature. Maybe it's something that should be it, and we need to communicate with the client better about how the program works. Remind, and then later that's sort of putting it on the back burner. We'll fix it later on, sort of things. And then there's all of these different flows in here of whether the bug was resolved. And finally, when it gets finished, we close it off and we wait for more bugs to come in. And this is a very typical bug testing or a bug life cycle. The bug comes in, we'd go through all this stuff. At some point, it's either going to be confirmed or basically put on the back burner. It's going to be fixed or put on the back burner at some point, and maybe we'll fix it later, maybe we won't. But bugs are important to understand. They are the basis of what testing is. We're trying to find them, we're trying to figure out how to stop them, and we're trying to make sure that the user never finds them, that we do first.